Hello. Let us try to understand today the basic principles of a voltage stabilizer. Stabilizing meaning we get a fairly constant voltage. That's how we call it voltage stabilizer. Before we go into that, let us try to understand some of the basic principles of voltage addition and voltage subtraction in DC. If we look at these two pictures, we have 4 batteries connected in series here, and here 4 batteries also are there, but then 2 batteries, one of the batteries is connected in a reverse way as compared to this. And when we power it, what we'll notice, it's very simple for us to understand. This gives us 6 volts because 1.5 into 4 is 6. Whereas here it is this volt and this volt cancels out, and actually you get 1.5 plus 1.5, 3 volts. So this is what is the basic principle of DC voltage adding and subtracting. Now let's come back to the AC operation. In AC operation we use transformers. Transformers for voltage up and voltage down. We call it step up and step down. Here we have taken a transformer which has a ratio of 230 volts to 12 volts. So while we apply the voltage here of 230 volts, we apply 230 volts here, we get 12 volts here. Because the turns ratio is the technical word which is used, but as a simple way that we should understand that if we feed 230 volt and the transformer is so designed, it will give us 12 volts. And if we give 115 volts, it will give 6 volts. Let's see that. So in this case, the transformer remains same, so the ratio remains same, 230 volts to 12 volt, and we are applying here 115 volts now. For example, when we apply 115 volts here, we find it 6 volts. But the transformer remains same, the ratio remains same, so whatever voltage we give here, we get exactly the same ratio, the output. Now let's try to understand how we add voltages and subtract voltages in AC operation, particularly in a transformer. We have the same transformer here, and then what we have done in the secondary side, see, for the transformer we have given some plus minus values here. The plus minus values meaning at that particular instant, if this is plus, this is plus, if this is minus, this is minus at that particular instant, because in DC we call it plus and minus, but in AC it is instantaneous value. Then we have to particular every half cycle. In a half cycle this is positive, this is negative. In next half cycle this is positive, this is negative. So addition subtraction takes place accordingly. So for example here when we give this positive, and what we have done, positive to negative we have connected and taken the output from here and negative. That means positive and negative, the voltage is bound to be increased because I have connected this voltage, this 12 volt in series with this 230 volts, so we get higher voltage. So once we operate this, what we notice, we give 230 volts, 12 volt is the secondary voltage, but actually it gets added up and becomes 242 volts. Similarly, for the buck operation, we have an arrangement here, again in series, but here the plus is connected to plus and minus we are taking minus to minus. In the process, the voltage is definitely to be reduced. And what we notice here, that when we switch on this, we find 230 volts, 12 volt minus, and 218 volts that we get. This is how the buck boost of the voltage in a transformer happens, and that is the basic principle of a voltage stabilizer. So one will wonder as to how do we really get this increase and decreasing the voltage. They are actually achieved by a set of relays. Relays are nothing but some electromagnetic switch. We call them electromagnetic relay. There's something like switch, and whatever arrangements we have done here, that connecting in series, connecting in anti-series, we get buck the voltage, and in same phase series we get boosting the voltage. All these are carried out by a set of relays, which are of course controlled by some electronic devices as using certain comparators or certain transistors. So for a voltage stabilizer, what we follow is that if our input voltage is increased by some reason, we try to buck the voltage by connecting in this fashion. And similarly, if the voltage is decreased for some reason, we try to boost the voltage by the other connection that we had seen. And that is how we call a voltage stabilizer. Stabilizer is not exactly that it will give you an exact voltage, but it gives a fairly good voltage tolerance, we call it, and useful for the gadgets that we